Welcome everyone to my talk. My name is Krystian Guliński. I work at Julia Hub, and I'll be talking about Dockerfiles for Julia, and especially about depot management. So what do we want when we build an image with Julia? So we want no compile at runtime, because we can do it at build time, so why would we do that? We want the smallest possible image size, because we have to attach the depot to runtime, but we don't want any things that might not be used, like some artifacts from a different package. And when we develop the image, we want no minimal recompile when we make some changes, so that we don't waste too much time. I'll be showing examples with the two following mechanisms that really help in achieving that. So with multi-stage builds, we kind of have the ability to branch off and run something in a separate stage, and then copy it over back to the main stage, and then discard that stage, so it doesn't end up in the final image. Another mechanism that I'll be using will be attaching cache to run commands. So for the time being of that single command, a temporary volume will be attached under the target path. And those caches can be reused across many builds. So once you're done with this build, you can reuse it in another one. So I will be keeping the Julia depot there, which is somewhat an uncommon use case. First, how do we get Julia into the image? We can use the official Julia image, Alpine, Debian, Windows variants. We can do the binary download. And as you can see here, I do it in a separate stage. I download the binary, unpack it, and then I copy it over back to the main stage so that I don't keep any of those artifacts in the image. There's also the Julia app version, but that requires more copying of those Julia app directories. But if you need Julia app in the image, this is always available. So I'll be using this package setup. So it's package A, depending on data frames, and package B. And when I will be rebuilding this project, I will be editing package B so that effectively we only need to recompile package B and package A. Data frames is kept in the cache, so we don't need to recompile that. So let's do no precompile at build time. And what you'll see is, obviously, please remember to set the CPU target, because you will probably run the image at some other machine. We copy over the project files, and then we precompile at runtime. And as you can see, the timings are awful. Even though the build time is quick, we pay the precompile price at every runtime. So this is not good to use. Now let's do standard precompile in a run command. As you can see, this is already far better because we do this build time once, and then at runtime we basically don't do any precompile, so it's just 1 second of runtime. The thing that you might see is that rebuilds take the same amount of time as the first build because we don't cache anything, so this will compile everything on each build. Now let's do a simple mounted cache. This is a method with 2 steps. So as you can see, this got a bit more complicated, but in the second line here, I'm mounting the depot. I'm mounting the cache under the path that the depot is set in, so root.julia, and I'm precompiling the project. What I need to do later is I need to mount the same volume again under a different path and just copy it over to the designated depot path. So using this method, I save 50 seconds on rebuilds because data frames is already precompiled. I only need to recompile package A and package B, which are maybe lighter, maybe heavier, but we still save some time. Runtime stays the same. What you have to notice here is that the ID needs to match, and those are global IDs, so it's best to have the same ID in a single Docker file. And sharing is private, so no other build at a time will use the same volume in a run command. So you might be thinking, do we have to do 2 steps? We can do 1 step, but I'm warning you, the first idea you might get will not work. As you can see, I'm doing the same thing. I'm mounting the cache under the Julia 2 path. I'm pre-compiling it to that directory, and then I'm copying it over to the designated depot path, which is root.julia. So this will not work because some packages are not relocatable. You will get issues at runtime. This example worked, but obviously you might hit a package that isn't relocatable. This is another method that tricks Julia into actually working with this method. So I first symlink the cache to the designated depot path. I precompile, then I remove the symlink. I copy over the depot from the cache to the depot location. And this should work. I haven't tested it too much, but this basically tricks Julia to precompile with the paths of the designated depot path. So even packages that are not relocatable should work just fine. So, and as you can see, this saves us a bit of time on rebuild because there's one step instead of two. So it's slightly faster. Now, you may be thinking, like some of my colleagues at work, what if we used one single depot for all of our builds? So you can do this with the shared parameter of this cache mount. But the problem is that that depot will have way too many things that you need. So, but you only want the things that you need in your specific project. So I developed this move depot script, which will be in the repo that I link at the end, which cherry picks whatever dependencies that you might need from the big depot and moves them over to a different location so that it's possible to share a big depot and across many builds and then just cherry pick whatever you need to a single image. So as you can see, this is used with the two-step method, but you can use it as well with the one-step method. It's just replacing the copy command at the end and doesn't really affect the runtime. It's a simple script with dependency only on package.jl, so that's super quick. Lastly, I wanted to show you that it's even possible to speed up cases where you have package compiler usage. So as you may think, but wait, like package compiler can't be really sped up. It's always, building the same image from scratch, and that's still the case. I'm not really helping with that. But what you can see here is that I start off as usual. Then I start another stage in which I will do the sysimage build. I will install G++ because that's needed for the build, but that's needed for not needed for my runtime. So I do it in this stage, which will be discarded later. I copy over the project files from the main stage. So anything before that will still get cached. We will not install G++ again on the rebuild. We will only do it once. And then I do the sysimage build. And please note that the CPU target is mentioned there in the command. This doesn't really get read from the env, so you might get issues when you build a sysimage and you want to, for example, run on a different platform. Then we get back to the main stage and we just copy over the sysimage. We copy over the depot using one of the methods. And as you can see, we save around 80 seconds on the rebuild, which is a lot considering this takes so much time. So that's all from me. You can find all the examples in this repo. And if you have ideas on how to improve the script, I would be very welcome. This is pretty hacky, but it works well for now. So that's all. Thank you.